Hello everyone, my name is Renu Jaiswal. Today we are looking at chapter 5, Square and Square Roots. This is such a fundamental chapter that whenever you will do calculations or any kind of word problem, most of the time you are going to use this concept. So study and learn it thoroughly. Let's get started. First concept here are square number or perfect square. What it is? Let's see. Suppose I'm taking number 3 and multiplying by itself. I'll get 9. Same way, if I take any number and multiply by itself, I'll get some number. So these numbers are perfect square or square number. The terminology we are learning here, you are going to see at many of the cases. In many situations, they will say, assume a number, it is a perfect square. So to solve that particular problem, you must know what is perfect square, correct? So here, perfect square is what? Suppose if I write 8, 8 is not a perfect square. Why? Because I don't have any number multiplying that itself, I'll get 8. So if I multiply 4 into 4, it is 16. 3 into 3, which is 9. So I do not have any of the number which gives me 8 by multiplying a number by number itself. So that's a square number or perfect square. What is exactly? If I get a number by multiplying a number and number itself. So if I have a, multiplying a by a itself, I'll get some number and that number is a perfect square. So let's see some properties related to square and square roots. So here is the chart. See, if I see the square of all these from 1 to 10, I have squared and the number written here in the table, like 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, and so on. I have written till here. Can you see? It is up to 25 and then 30 in the gap of 5. Notice here one thing. None of these squares contain 2, 3, 7 or 8 at the end of it. Means if a number is a perfect square like these number, at the end you will never get 2, 3, 7, 8. Like here I have 6, I have 5, I have 6, 9, everything. But I cannot see anywhere. These are the number. So I'm not talking about that. I'm talking about these squares that are perfect square. So see, you are not seeing all these numbers. So by simply seeing, suppose I have number 2, 4, 9, 2. As the end contain 2, I know it can't be a perfect square because none of is perfect square end with 2 or 3, 7 or 8. So this is one of the property for the square and square root. Coming to the next thing, here you can see if a number end with 1 like this, 11 is also ending with 1. Even 21 is also ending with 1. So their square will also contain 1 at its unit place. Like 1 has square 1. 11 has square what? This is wrong. 11 has square 121. So end is 1. Same way 21 square is 441, which is 1. So if any number ending with 1, its square will also have 1 at its unit place. Same way, if a number is ending 9, like 9, then 19, then 45, not 45, I'm sorry, any number which end with 9, its square will end with 1. So if a number has 1 or 9 as its unit place, its square will end with 1. Same way, if a number ends with 2, like 2 ka square 4, 12 is also ending with 2, same way 22. So its square will end with 4. Same way like 8. So if end number is 8, its square will end with 4. So 18 has 324 and so on. So 2 and 8 will end with 4. Likewise, if you notice, 1 and 9 will end with 1. 2 and 8 will end with 4. 3 and 7 will end with 9. 3 and 7 will end with 9. And same way 4 and 6 will end with 6. And the 5 number alone will end with 5. So this is one of the property. So if I say I have 26 square, what is the unit place in the answer? So I know if the digit is ending with 6, its square will end with 6. Same way, if I have 37 square, the unit place of its square will contain definitely 9. So this can be a one marker question in your exam. Hope you understood this concept. One more thing here, if I have suppose 100 and I need to find out its square. So if a number has number of zeros 2, its square will have number of zeros 4. Means squaring will double the zeros. Like if I have suppose 50, so 50 square is 2500. So if a number is 1 0 is there, in the square there will be 2 zeros. So here I have written a note. Square numbers can only have even number of zeros at the end. Like if I have 1 0, its square will be 2. If I have 2 0, its square will be 4. So it's always even number. So perfect square cannot have odd number of zeros. Clear? Here I have next few properties related to square and square roots. Some more interesting pattern. What are triangular numbers? Triangular number means, take one example. Suppose if I draw 3 dot over here and then 2 here, then 1. What is the number of dots? It is 6. Means 6 is a triangular number. Same way 3. I can draw 2 dots, then 1 dots. So it is 3. Same way if I take 4 dots like 1, 2, 3, 4, then here it will be 3, then here it will be 2, then 1. How many dots are there? 4, 3, 7. 7 and 3, 10. So 10 is also a triangular number. So whose dot pattern can be arranged as triangle are triangular number. If we combine two consecutive triangular number, two consecutive means the first triangular number is 3. Actually, first triangular number is 1 because 1 dot also is not triangle, but if you imagine it's just dot. So that is also a triangular number. So 1, 3, 6, 7. 1, 3, 6 and 10, they are triangular numbers. So if we combine two consecutive triangular numbers, suppose I take these two, we get a square number. So 3 plus 6, which is 9, and I know 9 is a perfect square or square number. Same way, if I add these two, again they are triangular number and a consecutive. So 6 plus 10 is 16 and 4 into 4 is 16. So this is again a triangular number. Adding two consecutive number will give you a perfect square. Like that, I have drawn dot for 4 base dots. You can try for 5 and so on. So you can comment me true triangular number after 10. Correct? Did you understand questions? If yes, please comment yes. So number between square number. So number between two square numbers. So two square number means what? Take one example. Suppose I have 2 chi-square, which is 2 into 2 and 4. Then I have 3 chi-square. 3 square, I write like this. At the foot 3 and square means superscript. So 3 into 3 is what? 9. Now, how many numbers are there between 4 and 9? I have 5, I have 6, 7 and 8. There are 4 numbers who are non-perfect square between two consecutive square numbers. So how many are they? They are nothing but these into 2 into the initial number, that is 4. Let's take one more example. Suppose I take the number, let me explain here. Suppose I have a number which is 4. So 4 is square. I can write 4 into 4, which is 16, and take another number. It says number between two square numbers. So I can take next consecutive 5. That is 5 into 5 is 25. Count how many numbers are there between 16 and 25. So it's a 17, 18, 19, 20, 21, 22, 23, and 24. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. It is 8. So what it is? It is nothing but 2 into the first number. That is 2 into 4, which is 8. So this is the second rule. Like number between square numbers, there are two non-perfect square numbers. That is, if you square a number and the n and n plus 1, okay? The square of the numbers n and n plus 1, there will be two n numbers which are going to be between them, and they are definitely non-perfect square. Hope so it is clear for you. See the next concept, next property of square and square root. Adding odd numbers, the sum of first odd natural number. Okay? Adding odd numbers means odd number is what? There are two types of numbers. One is odd and another one is even. So what is odd number? The one when we divide it by 2, we get 1 as remainder. And what is even? Even, which is getting divided by 2. For example, take 15. When I divide it by 2, I'll get what? 2 sevens are 14 and 1 as remainder. So this is a odd number. Take another example, 20. When I divide it by 2, what I get? I get nothing as remainder. So it is, quotient is 15, remainder is 0. So it is even number. Correct? So adding odd numbers, the sum of first n odd natural number is n square. This is n square. What it means? It means you take 5 odd numbers. That is 1. Then next odd number is 3. Then 5. Then 7. And then 9. These are the first 5 odd natural number. Correct? So I'm taking n is equals to 5. N means number of times you are taking odd number. So odd numbers are alternate. So I'm taking 5 odd numbers. That is 1, 3, 5, 7, 9. And they have to be consecutive. Consecutive means in a row. I cannot skip 5 here and take 11 over here. It has to be in the sequence. Add them. That is 1 plus 9, 10, 10. How much it is? 25. Correct? What I did, I added these to 10, then again 10, and then 5. It is coming 25. I have taken n as 5. So this is nothing but 5 ka square. It means how many odd number you will take, the addition of that odd number is nothing but it's a n square. If I'll take 6 odd number, the answer will come 6 chi square, that is 36. Take one more example. Suppose I'm taking 3 odd numbers, that is 1 plus 3 plus 5. I took how many odd numbers? 3. So 3 chi square is 3 into 3, which is 9. Check whether it's 9 or not. 5 plus 3, 8, 8 plus 1, 9. Yes, means this rule is working. Let's move to the fourth property. What it says, if a number is a square number, it has to be the sum of successive odd number starting from 1. Yes, it is true. Means it is same property as the above. Take one number. Suppose I am taking 16 and I need to check whether 16 is a perfect square or not. If a number is small, you can just try by 1 chi square, then 2 chi square, and so on. So it says it has to be the sum of successive odd numbers. Let's try. First odd number, the sum is 1. The second, third odd number is 3. The addition is 4. The next odd number is 5. So addition is 5. All these additions. So 5 plus 4, 9. The next odd number is 7. So 9 plus 7 is 16. As I'm adding the 4 odd numbers, the square will be 4 chi square, which is 16. And that is the fourth property. What the fifth property says, if a natural number cannot be expressed as a sum of successive odd natural numbers starting from 1, then it is not a perfect square. So basically, property 3, 4, and 5, all of them are saying the same thing. So if a number is perfect square, it has to be the sum of consecutive odd numbers. Here I want to show one pattern. Like any number which is in this pattern, like 1 square, then 1 square, then 111 square, so on. Means the number consists of only 1. That is, 1 square is 1. See, 11 square is what? I have 2 ones, so I'll write 1, 2, then again 1. Suppose if I have this number, 5 ones, so what I'll write? 1, 2, 3, 4, 5. Because I have 5, 1. So I'll write up to 5. Then again, I will return, that is in the reverse order, 4, 3, 2, 1. Like that, you can find the square of any number of which is consist of only 1. Suppose I have 1, 1, 1, 1, so many ones. Just count it. I have 3, 3, 6, 1, 7. And I want to find out the square of this number. So it's a simple as how many ones I have 7. So write it up to 7. 1, 2, 3, 4, 5, 6, 7. Then reverse it. 7, 6, 5, 4, 3, 2, 1. This is the answer. So that was about the concept. I will cover the exercise in the next video. As I'm saying, the videos are becoming very long, and in the pressure of that, I'm not able to explain in detail. So what are your views? Should I cover the concept separately and exercise separately, or you want me to combine in one single video? Please do comment so that I can improve my teaching method. Take care and happy studying. Bye-bye.